Okay, this is section 10.7. This is the last section in chapter 10. And we're going to start talking about how to actually graph circles on the coordinate plane. So I want you to recall one thing here. Remember y equals mx plus b. That was not the standard form equation of a line, but it was the equation of a line that we used a lot. And remember that in that equation, x and y didn't change. Really, we always had x and y in the in our equation when we put numbers in or whatever. The things that changed were m and b. M, remember, was the slope, and b was the y-intercept. Okay. Well, it's very similar when we graph circles. When we graph circles in our standard form equation up here, the h and k are what changes. The x and y stay the same. So in this equation, h comma k, that is your center of the circle. So it could be at 2, 4 or negative 3, 9 or whatever. That's your center of the circle. And r is the radius of the circle. Oops. The radius of the circle. Okay, so let's do an example of this. What I want you to be very, very careful of are these negatives in the equation. It's x minus h squared plus y minus k quantity squared equals r squared. Those minuses are really important. We'll see how they work in this next example, or in the first example. This one is pretty much a straightforward application of the equation, right? The standard equation of a circle with center at 0, negative 9, and r equals 4. Okay? Well, if this is my 0, 9 is my center, then this 0 is my h, and this negative 9 is my k. Okay, so h comma k. And so my equation then, and this is my r obviously, so my equation then is going to be x minus h, well that's x minus 0 squared, plus y minus k squared, and k is negatives 9, so this is where the negatives comes in. Y minus a negative 9 squared equals 4 squared. Okay, equals 4 squared. We can simplify this. Okay, if we simplify it, x minus 0, well that's just going to be x squared, plus y minus a negative 9, I'm sorry, that thing should be squared. Y minus a negative 9 squared, that's just going to be y plus 9 squared, equals 4 squared is 16. Okay? If that ever loads, there you go. Y plus 9 squared equals 16. So that's how we would simplify it. Alright? Very, very similar problem down below. Why don't you do that one on your own? And we'll move on to the third example in the lower, in the next row of boxes. In this one we have a point that is on the circle with center at 1, 3. Okay? And the only thing that we're missing is the radius, so we've got to find the radius here. So let's do that. What I'm given, if I kind of draw a mini diagram here, is I'm given a point on the circle and I'm given the center of the circle. A point on the circle and the center of a circle. And it's my goal to find the radius. Okay, to find that blue line, the radius right there. All right, the way I'm going to do that is using the distance formula. Okay, so the distance formula is d equals the square root of y2 minus y1 squared, x2 minus x1 squared. But I'm just going to actually do the problem here. So 6 minus 3 squared plus the x's, negative 5 minus a negative 1 squared. Okay, so I'm going to get rid of this circle diagram up here as best I can. Minus 1 squared. Okay? When I simplify that, I'm going to get down to d equals the square root of, let's see, 9 plus negative 5, so that's going to be plus 16, and d is ultimately going to equal 5. So 5 is my radius. I know my center is negative 1, 3, if it ever loads here. Yep. Okay, is negative 1, 3. So my equation of this circle is just going to be, let's see, x minus h, well, h is negative 1, so x minus a negative 1, that whole thing squared, plus, again, if it ever loads here, plus y minus k, well, that's going to be y minus 3 squared, which equals 5 squared. It's just 25 squared. And hopefully that all loads here soon. Right? There we go. Okay. So a couple important things. Really, just getting that visual in your head of what's going on is probably the most important part. Beyond that, using the distance formula, which you should be comfortable with by now, and then putting it right into the equation of a circle. Okay. Let's do the next example. Very similar, except now we can kind of look at it graphically. The point 3, 4 is on a circle with center at 1, 2. So 3, 4 is on a circle with center at 1, 2. So 1, 2, 3, 4. Oh, sorry, 3, 4. There's my point. The point on the circle. And then the center is at 1, 2. So over 1, up 2. There's the center of the circle. And my goal here is to find the radius. Well, if I'm very careful in how I draw my circle, then I think that I can draw and I can kind of estimate the radius of my circle. So in this one, it looks like it's going to be, if I count it up, it's going to be 1, 2, 3. It looks like even over here 1, 2, 3, and around the circle I think my radius is going to be 1, 2, 3, and I can use the distance formula to check it out, but it looks pretty clear that my radius is going to be 3. So r is 3 with the center at 1, 2. Alright, so the equation of my circle is going to be simply this. It's going to be, if that thing ever loads, the equation of my circle is going to be x minus h. Well, h is 1, that whole thing squared, plus sorry about the delay here, guys, plus y minus 2 squared, and that all equals sorry, 3 squared, or 9, 3 to the second power. Okay, and that's it for those examples. Let me wipe the screen here and move on to the last examples there at the bottom. Okay, now in this last one, I want to actually find the equation of, I'm given the circle, I want to graph it, okay? Well, I know a couple things from the graph here, or from the equation. I know that my center must be at 4, right? And this means, this plus 2 here means that it's going to be at negative 2, okay? So as my equation is normally minus, that's going to change to, if I kind of draw an arrow over here, that's going to change to y minus a negative 2 squared, okay? So that's where I'm getting my center. My center then is at my center is at 4, negative 2, And my radius then is 4, but it's got to be, this is, remember, in the form of r squared, which means that instead of it being 4, my radius is actually 2. Okay, so I would just graph these two things. My center is at 4, negative 2. The radius of 2, well, my radius is 2, I'm just going to count 2 units out from the center in each direction. 1, 2, that would be a point right here. 1, 2, give me a point here, point down below, and a point up above here. Here's my 4 points, and then I'm going to just draw my circle in. Okay, so that would be my circle. Alright, let's move on to the last one, and then we'll call it good. Once again, I have the equation of a circle, and then I want to find its area. Well, let me write this in more proper standard form, and maybe that will help us see what's actually going on here. This x plus 1, well, standard form has to have a minus, so it must be x minus a negative 1, meaning that my h is a negative 1 squared, plus y minus 3 squared, and that equals 3 squared. Okay, if it ever loads, that equals 3 squared. Okay, so that's how it's written in standard form. That must mean that my center is at negative 1, 3, with a radius of 3. Okay, so to graph that, I'm going to go to negative 1, 3, put my point down, and then my radius is 3, so in every direction I'm going to go out 3. So down below 3, over 3, up 3, and over 3, and draw my circle in. Formula for the area is pi r squared. I'll have you do that one on your own, and then I'll check it in class. So area is pi r squared. And that's it for this last section. Hopefully you found it pretty straightforward, and we'll work on it tomorrow in class.